Hello, everyone, and welcome to the Weekly Space Hangout for Friday, November the 11th, 2016. For those, I guess, in Canada and the States, a solemn Memorial Day / Remembrance Day to all of you today. So this week, we're going to be talking about a big surprise, the results of the U.S. election. We're going to be talking about what Trump's space policy is going to look like, and also, completely unrelated, is NASA preparing to abandon Orion. An exotic pair of stellar remnants, and Subaru's new planet imager. Joining us this week, we've got some of our regular cast of characters. We've got Kimberly Cartier. Let's see, Kimberly. That's
Hi,
not
Fraser.
Kimberly.
Hello, viewers.
There we are. Welcome to the Weekly Space Hangout again. Awesome to see you.
Thank you.
We've got Morgan Renberg. Morgan.
Hey, Fraser, it's good to be back.
Welcome back. And we've got two fresh faces. One who I think is someone you might not know in person, but you definitely will know him through his writing, and that is Bob King. Bob, welcome to the Space Hangout.
Thank you very much for having me.
So if you don't know, Bob is one of our columnists on Universe Today. He's been writing with us for many years now and has got a new and awesome book out, and we'll be spending some time talking to Bob about his book today. So hang on, Bob, and we'll get to you in a second because we've got our special guest from all the way from SpaceCamp, Pat Ammons. Welcome to the Weekly Space Hangout.
It's great to be here. Thanks.
All right, so we'll start with the interview portion of this episode, and then we'll move on. But before we do, Pat, can you give us that view? I know you were showing off your view outside the window. So can we just
Absolutely
see?
ready?
Yeah. Let's see. That's a space shuttle.
Oh, nice. That's wonderful.
That is awesome.
Yes, we also have a Saturn V here as well. Real deal, National Historic Landmark. So we've got cool stuff here.
All right, so let us know. Why don't you tell us who you are and what you do?
Well, I'm the communications director here at SpaceCamp and the U.S. Space and Rocket Center, which is home to SpaceCamp.
And for people who don't know, where is SpaceCamp located?
Maybe might surprise some people, but it's in Huntsville, Alabama. And why? Right? You guys know why.
Why don't you let people know why it's located in Huntsville, Alabama?
This is where the Saturn V rocket was developed. This is where we're the home to Marshall Space Flight Center. So this is where the rocket team came in 1950 to our Redstone Arsenal, which was a Army base that was sort of being phased out here, and they were looking for a place for the rocket team, and they came here to a little bitty cotton town in 1950 and proceeded to the town literally took off after that. We've had, 100,000 people a decade kind of joined our ranks since that time. And it's just a really smart place. Lots of people from all over the world working in space and defense industry here.
Yeah, I mean, I think a lot of people don't realize how much of the space program was developed across the United States.
Right.
We think of the Kennedy Space Center where all of the rockets launch, and we think about maybe Johnson Space Center where, some of the operations are done. And, we remember JPL, where all of the rovers and stuff are coming from. But in fact, there is representation and major centers across the United States, and a lot of the parts all came together. I know, those rockets, they had to be moved from where you are out to Kennedy Space Center, right?
Right down the Tennessee River. Correct. Yeah, we are. This is where all the propulsion work was done and is done. So this is where the Space Launch System office is located, and we're still. You don't get off the Earth without Huntsville. That's what we like to say.
That's awesome. So let's talk about SpaceCamp then. So now, what is it?
What is SpaceCamp? Well, SpaceCamp started in 1982, and it's an idea that kind of grew out of a comment that Dr. Werner von Braun made one time. And of course, Dr. von Braun was the lead scientist who led the team that developed the Saturn V. And he said, you know, we have football camps and band camps and dance camps, and we have all these other ideas that all these other places that help promote interest in young people, but we don't have something to promote science. You know, why aren't we getting kids excited about science and exploring space? And so it was kind of that kind of comment that out of which SpaceCamp grew. And so opened the doors in 1982. It was pretty small, little kind of a regional concept at the time. And now it is a internationally known brand with more than 750,000 alumni who have come through our programs, including 5 astronauts. Kate Rubins, who just came down from the International Space Station a week or so ago, is one of our 5 astronauts. And interestingly enough, all those astronauts are women so far. So we're waiting on this next class of astronauts to see how many of our alums are going to be in those names that get announced.
And are there any requirements? Can I, as a Canadian, come and participate in SpaceCamp?
Oh yeah, sometimes people will say, "Well, I can't come to SpaceCamp. I'm from Louisiana." I'm like, "Are you kidding me? We've got kids here from Australia and China and Dubai and India. People come here from all over the world, both children and adults. We have a very strong teacher program here too, where teachers who come, Honeywell Corporation sponsors a very big teacher program here, as well as Northrop Grumman, and we have our own SpaceCamp teacher program as well. Kind of that, come here, get the teachers inspired, little pebble in the pond, spread that knowledge and that enthusiasm. And it makes people understand why they're taking those classes that they need to take to become the astronauts, the engineers, the scientists, the doctors, all of those things that require those STEM subjects.
Yeah, I was talking to you before the show about this, that Dr. Pamela Gay, my co-host on Astronomy Cast, is an alumni of SpaceCamp and recalls it fondly. So,
Yes.
So what kinds of things will we learn at SpaceCamp?
Well, certainly you learn about the history of the space program. You're in an incredible classroom here. Obviously, you see the shuttle outside our doors, and that's not a flown orbiter. That was one that was used for testing purposes, weight, and how we're going to lift it up. You're not going to put a multi-million-dollar shuttle up on a test pad. First of all, you're going to test it out, and so we have everything that we have here, with one exception, is an actual artifact. Was used. It was a prototype. It was surplus, or it was used for testing. A variety of things. And so we have an incredible collection that can walk children and adults alike through the history of the American space program. From the very early days up through the shuttle, up through the space launch system. So we are the official visitor center for Marshall Space Flight Center. So you have a lot of NASA's work, but also what's going on in commercial industry as well. So you have that classroom that's a very physical thing that you can see, but you also get to take part in astronaut simulations. You get to do some, astronaut training simulations, some things, the multi-access trainer, which I'm sure your friend remembers fondly, being tossed, in circles on the gyroscope. We have, 1/6 gravity chair. You get to feel like what it feels like to walk on the moon, as well as our missions, which is one of the most important aspects of the program, where they actually go on a mission. In this case, we're moving as quickly as we can to a full Mars floor, where we're on the journey to Mars, right along with NASA. So.
And how long does it typically take to actually participate?
Well, for children, this typical week-long camp, it's a sleepaway. So you come on a Sunday and you graduate on a Friday. So you're here for the whole week. Now, the adult camps that we have are usually more of a long weekend. So it just kind of depends. And so we have a lot of, I was going to say I could turn my phone or the camera around, but I don't think you could really see outside the window our habitats over here. Little strange metal-looking buildings that kind of resemble some sort of space habitat. So that's where our dormitories are here on our property. We can accommodate about 1,000 people here on our campus.
Wow.
So, yeah. In the summer, when we're in full camp season, we'll have, well more than 1,000 children here. So it's really exciting.
That's great. And what ages for the children?
Well, we start as young as 7 if you want to come as a family. So that's a very popular program. We have parents. A lot of times it's lifelong bucket dreams for parents. They bring their children so they can get to go to space camp. But, sometimes they're coming back. They went to space camp themselves and they want to come back and kind of relive that experience and bring their child with them. And maybe the child's not quite ready to go away by themselves. Maybe mom and dad aren't quite ready to let the child go away by them.
Or they just don't want to let a kid go to space camp without them.
Right. Wait, they're going to let them have all the fun. So they'll come and experience that together. But for sleepaway, if you're going to come and stay with us, you have to be 9. You have to be at least 9. So 9 to 18 is the age for our youth program. And we have divided up.
13 and 15, so that might work.
Okay,
Yeah,
all right. It's really amazing. We hear from a lot of parents who tell us, I dropped this kid off on Sunday and I picked up a different kid on Friday. And I don't really know what you did, but, and a lot of it is what we try to do here is we try to talk to, STEM subjects are great. They're super important. We really want to emphasize why you need to take science, math and all that. But what's really important about our program is we teach teamwork. Teamwork and personal responsibility. And that is a really important thing that I think everyone walks away with here is you can't do anything by yourself. You do better when you're working with other people. When you share ideas with each other and find the best solutions by working as a team. And, it's the kind of thing that industry tells us all the time that they lack, and, that employees oftentimes lack that ability. So we really emphasize that and celebrate each person's individual strengths, certainly. But those strengths come together to make a successful team. And that's very important message that we promote every day here.
So I got a few questions that have come through from the audience. This comes from Nancy. Do you have any figures about how many countries have sent participants to SpaceCamp? So,
on average, every year we have close to 70 international locations. So we have a hallway of flags that has different countries that have come. But yeah, hundreds, of international countries that have been here. This summer we had children here from Morocco. We've had, China, as I said, we actually have more children who come from China every year than we do from Tennessee, which is our neighbor right to the north. So, it's about 23% of our attendees last year were, in 2015, were international. So they come from all over the world. And a lot of those sometimes are teachers through the Honeywell program in particular, since teachers from an international program, they send about 200 something teachers a year, and they come from, they'll be on a team. It'll be Kenya next to Colombia, next to, somebody from Minnesota, next to, it's an amazing opportunity. But our summertime, this time of year, we have a lot of school groups that come through. So they come in as a large group from, say, India comes over. But in the summers when our individual camp program is, and that's when you get a real mix of kids. Sometimes kids who've never met each other before, and they come and experience this and become lifelong friends, which is really super cool.
Yeah, it's really great. Fantastic. So I guess what is sort of the next event that's coming up that if people want to participate in SpaceCamp, how can they go about it?
Well, spacecamp.com, visit and I tell you what, if you want to come this summer, you better hurry, because we are selling out of weeks already. So it's really interesting. We've been doing this for a really long time, and we're really good at it. And it's an extremely successful program, but we certainly have seen a growing interest in space exploration, and I think that has to do with a lot that's going on with NASA and with commercial space right now. I think people kind of raised their heads a little bit and went, "Hey, wait, the space thing," and I think that we've had a real surge in interest, and so we're already selling out of weeks next summer. So, I would encourage any of the listeners out there, if they want to come, to go on and book their dates. We do have I'll go ahead and make this little sales plug. We do have a Black Friday sale coming up. The weekend after Thanksgiving. So it's a great way to save some money, save a little bit of money, and if you're looking for a great Christmas gift. So that's in a sales pitch. But that is, an opportunity for your listeners to take advantage of if they are, and then book your week because it might not be there if you wait too long.
Yeah. Awesome. And then if people want to follow you on social media, etc.
Absolutely.
SpaceCamp.
SpaceCamp USA and Rocket Center USA if you are a fan of the Rocket Center, which of course the U.S. Space and Rocket Center is where we're located.
Wonderful. All right. Well, Pat, thank you so much for joining us on the Weekly Space Hangout this week, and I look forward to attending.
Absolutely. Can't wait to see you.
All right. We'll see you later.
All right. Bye-bye.
Okay, so let's move on. Bob, if you're still...
I'm still there.
There you are. Okay, great.
Yes.
All right.
Good.
Let's bring you up and let's get on. Now, I just want to remind everybody that this is a live and interactive experience. If you're watching this live, go ahead and post any questions you like in the YouTube. And if you want to sort of take your fanship to the next level, go ahead and come join us on the Slack channel in the WSH crew. So you can just go to WSH-crew.net and there's instructions on how to actually join from there. So, all right, Bob, you are, of course, one of our writers for Universe Today, and we should have you here from time to time because you bring us just the best stories about observational stuff, comets, things that you can see in the night sky with some gear, no gear, but you've now done a book which falls right into this. What's your book? Do you have a copy of it? Can you hold it up? Or
I do, actually.
Right, let's see.
Here we go. Can you see it okay here? I got a little sunshine here in the kitchen, but...
Yeah, move it more.
Nice.
Yeah.
Hold on a second. We'll bring it into the...
Yeah, perfect.
Is that a little better?
Yeah, that's perfect.
All right. It's called Night Sky with the Naked Eye. So, and it's about all the... You could probably read it there. It's about satellites, planets, all the things you can see. And it's a remarkable amount of things you can see with just your naked eye. No telescope required.
And so your objective here was to give people what they can do just with their own eyeballs outside over the course of the year?
Yes, or any night. Just it can be. I have a seasonal star charts in there where people can start in spring and go all the way through the seasons. But then the other information applies at any time of the year. And there's lots of things to look at, starting with the most basic, like finding the Big Dipper, the North Star, and then moving on from there, using the bright star patterns and constellations to kind of work your way to other constellations. And I do it two ways. First way is the old analog method, where we just use our fists and point it at the sky and kind of hop from star to star, or you can get a planisphere. Yes.
Yeah, we mostly just shake our fist at the clouds here.
I know it. I deal with that too, but where you just take and use your fists to do it. Or also, I'm finding that, and you probably are too, that people really enjoy the phone apps now. And there are free star charting programs available. One's just called Star Chart, and you can download it in a couple of minutes, take it out, point your phone up at the sky, and you're there. You can see, and I'll have the outline of the constellations. It'll show the positions of the planets. And a funny aside on that is that I discovered that a lot of people like pointing their phones at the ground because they're fascinated with what's coming up or what's beneath the Earth. And of course, these apps will show that too.
So can you give us some examples of some of the cool things then that people can do over the course of the year? Even like what's coming up shortly that people might want to be able to do?
Well, the biggest thing right now, just very shortly, is the supermoon. And I know that there have been stories on Universe Today about the supermoon. So that's happening on Sunday night for the Western Hemisphere. That's when it'll be closest and easiest to see, November 13th. And then if you live in Europe, that'll be better on the 14th when the moon rises on Monday night. So we have the supermoon coming up. There's the Leonid meteor shower, but the very same beautiful bright moon that will make the supermoon will also damage the meteor shower. So the next really great event will be the Geminid meteor shower, come about December 13th and 14th. And in the book, I have the 10 brightest showers of the year with details and some maps, kind of where the radiants are. And I address that. And also some things that maybe you won't find in some beginning books is I talk about the night sky phenomena that are always out there, but that have nothing to do with the stars. They're like the halos around the moon, coronas, all these interesting atmospheric things that you encounter when you're out. And then, of course, a little beyond the atmosphere, the aurora borealis, and then the zodiacal light. So it goes into lots of different things that you can see. Some are faint, some are a little challenging, but most of the book is at a beginner level, and it deals with just the basic material.
So what? I mean, obviously, with the supermoon, people with good quality gear are going to be able to just barely tell that the moon's a little bit bigger and a little bit brighter.
Well, yes. Well, the best way to do it, and all you need is a digital camera. You might even be able to pull this out with a cell phone. Is just to take a picture of the moon on Sunday night, and then 6 months from now, when the full moon is at its most distant point from the Earth at apogee, take another picture, put those two pictures together, and you'll be able to see the difference in size. But Fraser, I also came up with, I really thought hard about this. How can we actually measure it? Some people really can see the size difference, all right? If they kind of lock in an image from a previous moon. But I kind of came up with a little device that people can make, and I put it on my blog today.
Okay.
I've nicknamed it the Supermoon Cider. You gotta have a name for your product, right?
Yeah.
And it's just an index card, and you take and you cut slots in the card of different widths. And then you take this card and you hold it out at arm's length, parallel to your face, as far as you can reach, and see which slot the moon fits into. And then you could perform the same experiment again at a different moon and see if you can tell the difference.
Right. I mean, one of the things that's kind of amazing here is just how like even people always think the moon just looks so big on the horizon. It's so much larger, but use that same technique. I always recommend people hold out their arm, put up their pinky finger, see how the moon just barely covers the moon when it's down at the horizon, and then later on when they think the moon looks much smaller, do it again, and we'll see the moon actually hasn't changed size at all. It's the same size it always was.
It's the same size always, yeah. And it's such a funny irony that the full moon, when the moon is at the horizon, and you guys know this, it's actually further away from the Earth by 1.5%, because we have to look across the curvature of the planet to see to the moon. And then there's the moon illusion too. That's going to make the moon bigger than anything anyway. So that all plays into it. Extra big full moon this weekend. And
so when is the book out?
The book was just published, as a matter of fact, this week, November 8th. And so it's been out, first and available for pre-order, but you can pick it up at Amazon and Barnes & Noble's, IndieBound, and it's at various Barnes & Noble stores. So I've done some checking around, and a lot of people have received copies there. So it's available.
That's fantastic. How did you enjoy writing? Was this your first book?
Yes, this is my first book. And it was... there were times, when you come up with the right description or sentence and you're in flow, feels fantastic. When you get stuck, it can hurt at times. Yeah. So you just have to keep working through it. So
I will never write another book.
I know you've written.
I've written 3 books, and I will never do it again.
And why is that?
For what you just said, it is agony to sit down and write, that many words and try to bring it together as a cohesive concept. And no, it's hard. It's so much work.
It's tough. I heard a great description of the tougher parts, the moments when writing really gets difficult. A well-known author wrote this book called The Underground Railroad, and he described it as crawling through glass. I did have a few of those moments. Yeah. But then there's the joy, too, of getting it right and then seeing it flow. And it was all a mix like that. And I'm so happy it came together.
And actually, Nancy Atkinson has done a book as well, and it was expected to come out sort of around the same time. And unfortunately, it's going to be delayed until just before Christmas. So we're going to have Nancy on to talk about that, which is all about space exploration stories, which is going to be pretty exciting.
I'm really looking forward to that book.
And we've got another book as well, which is Dave Dickinson is going to be releasing a book about 101 things to see in the night sky for next year, 2017. And we're going to be releasing this actually free on out of Universe Today. So you'll be able to, everyone can just download a free copy of this book for next year. So we've got a lot of good material coming out, not just out of Universe Today, but also with some of the writers, which is pretty cool. We're moving over to the mainstream. That's what's happening.
Well, I just find it's wonderful news to see so many people interested in the sky, whether they just want to learn more or it's through space exploration and NASA missions. I think it's all a good sign. I teach classes and I also do planetarium shows, and there is no lack of interest over the years, many years that I've been teaching it, just from the public, people that just want to know a little bit more about space. And that's who this book is aimed at, is to learn more in order to more deeply appreciate the heavens.
And I think that's always my advice, right? Is that when people want to get into astronomy and they're like, yeah, but I don't want to have to buy a telescope and they're like $1,000 and I don't even know how to use it. You don't. You've got two really fantastic scientific pieces of equipment in your skull that you can use to begin that journey and really start to understand and appreciate your place in the universe. And then you can add fairly modest pieces of equipment, like a pair of binoculars that isn't going to cost you very much, and go from there. So, I think this is. I haven't seen any other books that do this, that really give you that concept of what you can really do without all of that fancy gear. So that's really cool.
Yeah, and the book is also geared towards activity, and that's the main thing, is to be able to get out. So there are a lot of little boxes in the book highlighted where it encourages you to go out and say, look at a star in Perseus whose light changes, the star Algol, or to look for the Earth's shadow when the sun sets. Some of the things are very simple and easy to do, and I think people will be amazed at what they can see or what they've been missing, perhaps.
All right, so hold it up again, Bob.
Here we go.
See one more time, the book.
Okay, let's see if I can get into a better spot here.
It's got the naked eye.
It has a lovely cover. It's all in color too, so it has some nice pictures.
Fantastic. Awesome.
Thank you.
All right, well, thanks for joining us quickly, Bob. I want to, as one of our writers, I'd love to kind of help you get the word out, help you sell more books. So good luck, and I know you've already done sort of one excerpt. I think there's probably going to be more information coming out on Universe Today as well to sort of continue to promote it over the next year. So good luck. Thanks a lot.
Thank you for all your help. Thanks for having me on.
No problem. All right, let's move on with the news. And I think, Morgan Redberg, we got to know what's going to happen with now that Trump is the president-elect of the United States. Is that how that works? He's your prime minister? How does this work?
President-elect, that's right. On Tuesday, the American people selected him to be the 45th president of the United States. And now we have this period between the election on Tuesday and inauguration in late January, in which he has to work to put together his team to figure out what his policy positions will be. And that leaves people in all sorts of industries all over the world sort of wondering how will their field be affected by the changes in policy that inevitably come with any presidential change. And this is particularly challenging after this election because Donald Trump was a candidate who didn't espouse too many specifics when it came to the policies he intended to set forth. But we have learned a little bit in the last couple of weeks about what he intends to do when it comes to space policy. One of the things that we can be sure he's interested in doing as part of space policy is to separate NASA from the study of climate change. And so he has proposed, or his advisors have proposed, that NASA is not the appropriate agency to oversee climate change. And that should be switched instead to NOAA, the National Oceanic and Atmospheric Administration. And that NASA should basically hand over that research to NOAA, which in and of itself isn't a particularly unreasonable idea to have. But people across the political spectrum expect that to come with a pretty substantial cut in funding for climate science research in general. And some of that money might then be reinvested into NASA's space science endeavors. And one thing that seems likely is that President Trump will suggest that NASA focus more on the long-term human exploration of space, especially pushing out beyond Earth orbit. He intends to do as much as possible to hand over the space activities sort of in low Earth orbit to private companies. And this is actually an extension of the policy adopted by President Obama, who has contracted with people like SpaceX and Boeing to start delivering cargo to the International Space Station. I think we can expect President Trump to accelerate that process and try to refocus NASA on putting humans further and further out into space. At least one prominent Trump advisor also is pushing for including the moon once more in the NASA's roadmap for getting to Mars. And so we've kind of flip-flopped back and forth about this for the last couple of decades. The second President Bush made going to the moon within the coming years one of NASA's top priorities. But when President Obama took office in 2008, he redirected NASA away from the moon and towards the asteroid redirect mission, or the asteroid rendezvous mission, as a stepping stone to Mars. And it's quite possible that when President Trump takes office in late January, he will instruct NASA to abandon the asteroid redirect mission and return to a plan that focuses on returning to the moon first, establishing human presence on the moon, and then pushing forward to Mars. And I mean, I've said for years now, and others have said it for much longer than I have, that the one thing that's holding back NASA more than anything else isn't funding, it's not technical capability, it's not the people that are working for it, but it's the constant shifting in priorities. Because putting together even the smallest of space missions is an endeavor that takes 5, 10, 15 years. And when every 4 to 8 years you're restarting your goals and starting from scratch again, then you can never hit the 10-year mark in which you actually get something off the ground.
Yeah, that's how I really feel, right? Mission to the moon, fine. Mission to Mars, great. Mission to an asteroid, also fine. Just any of them would be fine. A better, bigger, maybe rotating orbital space station that starts to, learn the methods of artificial gravity, excellent. Just stick to something for the duration. And so, once again, new administration comes in, they've got different priorities, they mix things up, and all that momentum just goes out the window, and now we're on a new direction.
Right. And it's too early to really know exactly what direction his administration is intending to take NASA. But probably the first sign that we'll have is who they appoint to be NASA's administrator. It's traditional that the heads of all federal agencies offer their resignations to an incoming president, who then has the opportunity to replace them or retain them. And who that person is can often say a lot about the priorities that president will have. For example, President Obama appointed Charlie Bolden to be the administrator of NASA, and he was a former astronaut. And in the last 8 years, President Obama's budgets have focused more on human spaceflight and less on NASA's science missions, with the exception of climate change, than we saw previously. And so if President Trump appoints someone who is an astronaut or someone tied to the spaceflight industry, for example, to be the head of NASA, then that might be an indication that human spaceflight is likely to be the focus. If he were to instead appoint somebody with a scientific background to lead the agency, and many people think this is probably pretty unlikely, then that could signal a return to a science-focused approach for NASA. But again, that science-focused approach would be looking outwards on the other planets and the universe, not inwards at planet Earth.
Yeah, I mean, I've actually sort of ranted about this in the past, that I really feel like having this dichotomy between science and exploration is a false dichotomy, that both are important and both should be done, and it's crazy to have people have to fight over the budgets about whether we should have more science or less science, or we should have more space exploration or less space exploration. yes please to all of the above. We should have more science, and we should have more space exploration, and
that costs more money,
and that costs more money, right? So maybe,
and that's a thing we're unlikely to see
right, exactly,
expended in a Trump administration.
Yeah. I mean, well, we don't know. I mean, again, we just don't know what's, until, I mean, we are in this moment of massive speculation while everyone is kind of picking their jaws up off the ground. Now we move into this next stage where people try to figure out what's going to happen next, and we're
it has
still
to
months
come
away.
quickly, because the first responsibility of a president taking office is to propose a budget to Congress. And sort of a common refrain in Washington is that where you put your money is where your real priorities are. It doesn't matter what you say. It doesn't even really matter who you put into various positions. It's where you put the money. And so in February or March of next year, he will have to propose a budget to Congress, and that will lay bare the priorities for where he intends to take NASA.
Yeah. So I guess what you're saying then is that we don't really know yet, but we're going to find out soon as he defines that budget.
There'll be a lot of news in the coming weeks.
Yeah, for everywhere and everyone, and hopefully you'll be able to come back and tell us, as we actually get some details about where the money is going to be spent, we can understand what that might mean for some of these long-term missions. So I think that's great. Thanks a lot, Morgan. All right, Kimberly, let's talk about, I don't know, which one do I want to talk about? Pick one.
Let's talk about planet imaging.
That sounds great.
Awesome. So the Subaru telescope just got a new planet imaging instrument. It has a really long name, the Coronagraphic High Angular Resolution Imaging Spectrograph, which shortens to CHARIS, because we love our abbreviations in astronomy. And this instrument is actually very, very powerful. It's a combination of a coronagraph, an imager, and a spectrograph all in one. And it was installed recently on the Subaru telescope, which is an 8-meter telescope down in Hawaii. Collaboration between Princeton and the University of Tokyo and the National Astronomical Observatory of Japan, which means it has lots of power and backing behind it. And this instrument is capable of not only seeing the light that's coming off of the planets themselves and not the stars, but it can separate the light of the planet from the star, image it, and get a spectrum of that light all in one.
Okay, so
yeah,
that's cool.
That's very cool.
So what will that let us be able to do?
Right, so let's break that down. So the coronagraph itself is a new design, which is designed specifically. It goes in the light path of the telescope, and it creates an interference pattern which gets rid of like 99.99% of all the starlight. So it can focus in on just the light being reflected or being emitted from the planets themselves to almost an unprecedented precision.
And we've talked about coronagraphs in the past as this thing floating in space with like a petal shape that floats like maybe 10,000 kilometers away from the observatory.
I mean, yeah, you can build things like that, star shades that go in space. This one is actually in the telescope itself in this instrument. Sort of similar to how the Gemini Planet Imager has a coronagraph on it, but this one is designed specifically for Subaru. And so the coronagraph is doing a great job already at filtering out that starlight because the planets are just so faint in comparison. And then it has an imager, so you're getting a picture of where actually the planets are in relation to the stars, so direct imaging of these planets. And you're also getting a spectrum of the planet light at the same time.
Again, I think you're too deep into the science here to really get excited enough about what that means, right? Because, I mean, this is like you're blocking out the light from the star, and then you're seeing these little planets around the star. And then you're knowing what the
mass is, what the temperature is, what the
spectra
atmosphere
of
is
the
made
planets. You're knowing what the atmosphere of the planets are, which is I've been going on about this for years now, right? We are closing in on the Holy Grail.
Exactly. I mean, I've said as well is that the atmospheres of these planets are really what make them unique and what really make them what they are. I mean, we could wax poetic about habitable zones and orbital distances, etc. But what's actually happening on the surfaces of these planets is 100% dictated by the atmospheric composition. And that's where we're starting to go. And nowadays, we can get spectra of atmospheres now before this new instrument, but it takes hours upon hours and multiple instruments in order to actually get a good understanding of what these atmospheres are doing. And now with this new instrument, we may be able to get that understanding with, one set of observations from Charis, which just sort of it increases the power of these observations by like 10 or 100 times.
Right. And so right now we see planets, we calculate their mass based on the way they wrench their star around, and we can kind of get a sense of like, based on how quickly it takes them to go around, we know where they are, whether they're in the habitable zone based on the brightness of the star. But in this case, we will actually be able to see the atmospheres of these worlds and say, that is a terrestrial world. It has the kind of atmosphere that we would expect to see for a planet that is within the habitable zone.
Yeah.
Yeah.
We are going to start trying to probe that type of science all at once.
How far out from us, how far away are we going to be able to resolve these worlds around these stars?
So the instrument itself has a field of view of 2 arcseconds, which is incredibly small. So I think they did some of their calibration images looking at Neptune, the atmosphere of Neptune, and they could not actually get all of Neptune on the detector all at once.
Wow.
So they're going incredibly fine detail.
Yeah.
It's on an 8-meter telescope, which means it has a great deal of light collection power, so we can see very far, very faint things. And the precision of the coronagraph means that we can filter out the starlight to unprecedented level of precision, so we can see cooler planets that are closer by their stars. So we're going to probably go out to a few thousand light years. We're not constrained to the very young stars and the very young planets that are very hot. And we're not constrained to planets that are too far away from their stars to actually be in the habitable zone.
Wow.
Yes. So they just got first light. They're going to start taking science images in February, hopefully. So.
Yeah. Yeah, that is just like I said, I am so excited. I think this is one of the most amazing accomplishments that's come out in sort of space science in the last couple of years. That, we're also excited about James Webb and what's going to happen from out in space, but to be able to build an observatory that is capable of seeing these planets from the ground, where you can go back and you can tinker and you can put a new instrument on the back of the telescope and upgrade it. To be able to do this stuff from the ground is absolutely fantastic. You don't have to worry if your spaceship is going to get destroyed in launch. Like you just go back and fix it. It's right there. It's it's in Hawaii. So I'm
great.
Yeah.
You can visit it. You can fix it. You can adjust the wavelength range. Oh, I also didn't say this instrument goes across a very wide wavelength range, which we don't normally get to probe from the ground, and we don't normally get to do this entire wavelength range in one go. So like Hubble can do a small chunk, and James Webb will be able to do a small chunk, and Spitzer can do a small chunk of the wavelength range, and this Charis can do a very wide wavelength range. You get as much as possible all at once.
So we've got a question here from Michael Meyer. Kimberly, does it see planets by emitted or reflected light?
I believe it could do either, but you'd be looking at very different types of planets. So if the planet is still emitting light itself, it's either a very, very young planet that's just formed and still has a lot of heat, or it's very close to its star and is actually being heated up internally from the star. If you're
Jupiter's
looking...
still emitting light, isn't it, Kimberly? Jupiter emits more radiation than it receives.
It does, but it's in farther into the infrared. It's still pretty cold. So you'd be, I think the type of light that Jupiter is emitting is outside the wavelength range of Subaru.
Right.
But you could do reflected light as well.
Well, please let us know when it's discovered aliens.
I really hope so.
Yeah.
You'll be the first to know.
Or at least a world, instead of it's in the habitable zone, where like it has liquid water or water vapor in the atmosphere or things like that, that we can get a much better sense of what's going on in the world. That's just awesome. All right, we'll move on. Back to Morgan. Let's talk about whether or not they're going to kill Orion.
All right, this is a bit of information that leaked out this week that suggested that back in late October, NASA circulated what's called an RFI, a request for information, to a variety of aerospace companies. And requests for information is sort of NASA's absolute sort of bare bones first step. They're looking for ideas, as it suggests. And the subject of the RFI was whether various aerospace companies could modify their space capsules to meet the mission parameters for Orion. And so as a reminder, the Orion capsule is intended to be NASA's next crewed capsule for travel throughout the solar system. It replaces the space shuttle. It looks much more like, say, a larger version of the Apollo command module than anything else. And it's being designed and built by Lockheed Martin, but it's terribly behind schedule. When it was originally commissioned from Lockheed, the intention was to have the first crewed launch in 2014. And now the intention is to have the first crewed launch in 2021. And so that puts them at least 7 years behind schedule, and they've already spent more than $10 billion developing it. To put that in context, that's a little bit more than's been spent on the entire James Webb Space Telescope project, something that's been considered kind of a budgetary disaster in its own right. And so what it sounds like NASA is considering here is completing Orion to sort of its most basic level of functionality. And then stopping there, not funding Lockheed to develop it further, and to at that point evaluate whether Boeing could alter its CST-100 space capsule that it's developing to deliver crew to the ISS, or whether SpaceX could alter its Dragon capsule. The Dragon 2 we know is designed to be capable of carrying a number of crew into deep space. And right now, these companies are developing these primarily to ferry astronauts to the space station. But they're doing it at a much, much lower cost than what Lockheed is spending to develop Orion. And so this is another example of NASA thinking about changing directions pretty late into a project. And all of this was done before the presidential election, which, regardless of which way it was to go, likely would have signaled changes in priorities for NASA. So we already have NASA, independent of a new administration, thinking about changing direction when it comes to human spaceflight. And now that's going to be combined with changing priorities from the Trump administration.
Yeah, I mean, a lot of this, I know this is a completely separate conversation from what we talked about before, but, because this isn't necessarily any of the directives that Trump is necessarily going to be pushing forward, but a lot of this really hinges on how successful SpaceX is in its own essentially completely alternative method that's going to follow the same thing. The Dragon capsule, and especially the Red Dragon, will fulfill a lot of the same capabilities of the Orion capsule. The Falcon 9, the Falcon Heavy, the BFR are going to be very similar to what NASA's in development with the SLS system. So there's a certain point when if you're developing something and it's massively more expensive and you can just go and buy it off the shelf, it's going to be really tough to just continue the development of this program. But
there are many people in the space industry who say, well, the federal government doesn't build its own trucks and cars. It buys them from Chevy and Ford and Toyota and what have you. And they shouldn't be building the cars of space either. They should be buying them from the lowest bidder, whether that is SpaceX or Boeing, or if Lockheed wants to get their act together and design something else that's competitive with these other options.
Yeah, and I mean, I'm more of a pragmatist. I mean, I personally really feel like NASA's biggest job is to help the industry, help people take on the kinds of risks that a company would never do, and if that is developing new kinds of rockets, new propulsion systems, figuring out how to be out in space and live and work in space, and if nobody wants to take that on, that is I think that's the kinds of things that NASA can really help push those things forward. But at the same time, if they are literally, as you said, building trucks when you can buy trucks, then, and somewhere is that line in between pushing new ground.
Government builds tanks and buys trucks.
Yeah.
How do we find that same balance in space?
That's exactly it. Yeah. And so which one is it going to be for this? So I think that is, as SpaceX, if SpaceX is more successful, then we will have a better sense on whether it's a truck or it's a tank, whether it's whether it's something they can buy off the shelf or something that they're going to have to continue the development of. Where do you think it's going to end up?
I think that it's probably increasingly likely that we'll see more and more off-the-shelf commercial products. If for no other reason than in some strange way, there's more continuity in private enterprise when it comes to space than in the government. Because SpaceX has been able to undertake the Falcon and the Dragon program since the middle of the Bush administration, and carry that all the way through into the Trump administration. And NASA hasn't had that capability. And so when you talk about needing a lot of time, it's not like private companies are faster than NASA at really putting this stuff together, but they have this long running time to work on it. And that may sort of prove to be the savior of these long duration space programs.
Yeah. All right, Kimberly, we've got one last story from you to wrap up today's Weekly Space Hangout.
So one of my favorite things to talk about is strange stars that are doing strange things, and we don't quite understand why. This is a different star system than I usually talk about,
right.
But it is still
no
very
alien
strange.
megastructures today.
I didn't say it. You said it, not me. So this star system has two stellar remnants in it, which is not unusual in and of itself. It has a white dwarf and it has a pulsar. White dwarf pulsar binaries are not uncommon at all, but usually when you have a white dwarf and a pulsar, they're in very tight, very circular orbits, circular to 1 part per million on average, because the two objects are very massive, very close, and so their tidal interactions tend to circularize the orbits. But what we've discovered is a particular white dwarf pulsar system that has a very eccentric orbit, which we definitely would not expect from two such objects. This is the fifth system of this kind that we've actually discovered, where you have a white dwarf and a millisecond pulsar spinning very, very rapidly that are in very eccentric orbits. So what we're likely seeing now, we're starting to get the idea that we're actually seeing a new mode of stellar evolution, something happening in the physics of these two, in the system with these two objects that's causing some sort of decircularization, if that's the correct word to use for that, some sort of gravitational interaction or physical interaction between the two stars that is causing them to sort of become more chaotic than they really should be. Which we still don't understand quite why that's happening, but we're starting to find more and more of these systems that have very similar masses and orbits and eccentricities. So there has to be something that happens not too rarely with these types of stars that's causing these eccentric stellar remnant systems.
Any theories?
A few theories. Essentially, they all involve some sort of material interactions between the two systems. So the white dwarf, which is sort of about 1.4 solar masses or so, they're thinking maybe there is some sort of remnant circumstellar disk from when the star went from a star to a white dwarf. expelled a bunch of material. Maybe some of that material went into a circumstellar disk, which sort of acted like a third body that distorted the orbits of the two objects. Maybe. We don't have evidence for that, but it's a possibility. There could be some sort of really strong stellar winds that cause an interaction between the two objects. Or maybe the problem isn't with the white dwarf, but maybe the problem's with the neutron star or the pulsar, and some sort of, when the neutron star became a pulsar, there was some sort of energy release that made the system more eccentric than it should be. It's all very speculative at the moment.
Right, but I mean, to get one of those, a neutron star and then eventually a pulsar, you needed a star that was many times the mass of the sun, and it died as a supernova.
Something like 10 to 20 times the mass of the sun that died in a supernova and left a very dense, very massive neutron star core that somehow got spun up and has a strong magnetic field such that it releases pulses, a beam that sweeps by as it orbits. There's some sort of energy conversion, energy interaction that's happening. We just don't know.
Yeah.
We just don't know.
It's,
it'll be
I mean, with a lot of these really dynamic situations, I mean, the more of these surveys that are going to get done, and I, always bring this back to the Large Synoptic Sky Survey, the more of these surveys, the more of these really interesting, multiple star systems with these combinations of pulsar and white dwarf and multiple pulsars, multiple white dwarfs, and their interactions and their final kind of, when they crash into each other and detonate and create gravitational waves and things like that. We're going to be able to study these in more and more ways. So
yeah, I mean, I think we like to teach and we like to explain that stars are very orderly. They go from A to B to C throughout their lives, and they interact in very controlled ways. But what we're finding more and more as we discover more of these systems is that essentially every single one is unique, and they have their own individual interactions, and they produce very unique configurations in their end stages. So we like to teach that everything's all nice and uniform, but we're starting to find that it's not actually true.
Well, even, I mean, as we learned like in the last couple of weeks, even our own solar system, the sun is tilted a couple of degrees off of its own, the disk of the solar system. And so even there are strange things happening in our own solar system that perturbed it in ways that we weren't anticipating. So not surprised. Weird stuff is going to be found, especially stars that, for example, are, giving us some kind of light system that can't be understood.
I don't understand. I would personally like to find more of these stars, the white dwarf pulsars, not the other kind. I would like to find more
megastructures, right?
Yeah, try and start to figure out what they have in common. Maybe see if we can find something that hasn't yet evolved into this type of system to try and sort of start to piece together what this mode of stellar evolution might actually look like.
Fantastic. All right, well, now's the time when we reach the end of the show. I know we've sort of reached the end of our hour. Thank you, everyone, for joining us this week. Kimberly, I'm going to, since you just talked, and give you another chance now to let people know where they can find out more about what you do out there on the internet. Kimberly, where can people find out more?
Sure. People can always find out more by following me on Twitter at AstroKimCartier, or by going to my website, KimberlyCartier.org.
Fantastic. Morgan, where do we find out more?
You can follow me on Twitter at Morgan Renberg, and visit my website, morganrenberg.com.
And Bob, you stuck around. Where can people find out more?
Well, on Twitter, you can find me at astrobob _BK, or you can go to Universe Today, where you'll see an article pop up every once in a while, or my blog at astrobob.areavoices.com.
Wonderful. And of course, I'm Fraser Cain, publisher of Universe Today. If you haven't already, subscribe to this channel. I promise next week you're going to have a really exciting couple of videos coming out. A monster, 25-minute plus episode all about colonizing the solar system. So if you haven't already subscribed, you'll want to do that now. Thanks to everyone from the Weekly Space Hangout crew, all the people in the chat, all the people in the Slack. thank you for joining us. There's no astronomy cast this week. Pamela's voice is kind of trashed, so we're going to push that back to next week. We're going to be doing an episode on the moons of Mars. So we'll be doing that. I guess it's going to have to be next week. She's traveling quite a bit, so we'll have to figure this out. So thanks, everyone, for joining us. Thanks to the guests. Thanks to all of you people watching. We'll see you all next week. Let's see if we can go to everybody here. Hold on. We all got to say goodbye. There we go. Goodbye.
Bye.
All right. Thanks, everyone.